Hello students, welcome to Tungal online classes. Today I am going to start fourth distribution, that is hypergeometry distribution. We have already studied three distributions. One is Barlow distribution, second one is binomial distribution, third one is Poisson distribution. Okay, this is the fourth distribution, that is a hypergeometry distribution. Okay. It is also discrete probability distribution. It is also discrete probability distribution. Here, Bernoulli, binomial, Poisson, and hypergeometry distributions are discrete case, and remaining three are continuous case. Remaining are, that is normal distribution, Kaiser distribution, and student case distributions are continuous case. Okay, here it applies to sampling. Okay, this method, hypergeometry distribution, applies to sampling without replacement from a finite population. It applies sampling without replacement from a finite population. Okay, finite means that is countable, whose elements can be classified into two categories. Whose elements can be classified into two categories. One which possesses the attribute, and another which does not possesses that characteristics. One is one which possesses the characteristics, and another which does not possesses that characteristics. Okay, ಏನೋ ಒಂದು ಹೊಂದಾಣಿಕೆ ಆಗುವಂತ ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಇರ್ತದೆ, ಒಂದು ಹೊಂದಾಣಿಕೆ ಇರಲಾರದಂತದ್ದು. Okay, here the categories could be male, female. Here the categories could be male, female, employed, unemployed, male, female, employed, unemployed, married, unmarried, educated, uneducated, literate, illiterate, etc. Okay, these are the categories. These are the two categories. Here male or female. Okay, one which possesses the characteristics and another which possesses the characteristics. One male. Okay, and another one is which does not possesses that characteristics. That is male, opposite is female. Here employed, unemployed, literate, illiterate, educated, uneducated, married, unmarried. Okay, these are the two characteristics. One is male or female, employed, unemployed, etc. Okay, here the hypergeometry distribution follows the conditions categorize the hypergeometry distribution. Here there are two conditions are there. The conditions, the first one is the probability of success changes on each draw. The probability of success changes on each draw. The probability of success changes on each draw. Second one, the results of each draw can be classified into two categories. The results of each draw can be classified into two categories. Third one, the draw is fixed number of times from an infinite population. From a finite population. These are the three conditions involved in the hypergeometric distribution. 2 marks. These are 2 marks question. What are the conditions involved in the hypergeometric distribution? Here, the following conditions categorize the hyperdistributions are. The first condition is the probability of success changes on each draw. The probability of success. Here, tossing a coin once, it may be head or tail. It may be success or failure. Here, the probability of success changes on each draw. First time success aಬಹುದು, second time failure aಬಹುದು, fourth time success, fifth time also success. Okay, here the probability of success changes on each draw. Yavatlu changes agtadha, one fixed irangilla. Okay. Second condition, the result of each draw can be classified into 2 categories. Here, the results of each draw can be classified into 2 categories. Here, the result of each draw. Here, result. Heading is result. It can be classified into pass or fail. Pass or fail. The result of each draw can be classified into 2 categories. One is pass and another one is fail. It is pass or fail. It can be classified into pass or fail. The result of each draw can be. Okay, next, peoples. Okay, it can be classified into men and women. Okay, literacy. Okay, educated, literate, illiterate. Literacy. It can be classified into literate and illiterate. Here, the results of each draw can be classified into 2 categories. The next one is the draw is fixed number of times from a finite population. The draw is fixed number of times. Fixed. Okay, particularly n time. Here, tossing a coin n times, throwing a dice n times. Here, the draw is fixed number of times from a finite population. Here, population should be finite. Means that is the population should be countable. Okay, these are the 3 conditions involved in the hypergeometric distribution. Okay, next concept is, for example, consider an earth contains A white balls and B red balls. Consider an earth contains A white ball and B red balls. Okay. Here, suppose we draw a sample of n balls at random. We draw a sample of n balls. N balls are out of, okay, total probability. N balls are randomly selected. Okay. Suppose we draw a sample of n balls at random. From finite population. From an urn. Then X white balls can be drawn from. X white balls can be drawn from A white balls in ACX ways. Here X, okay, out of, here X white balls can be drawn from A white ball. Out of A white balls, X white balls are drawn in a ACX way. And n minus X red balls can be drawn from n minus X red balls can be drawn from B red balls in in BC n minus x ways. In BC n minus x ways. Here n minus, okay, out of n minus x balls, red balls, B balls are drawn in BC n minus x ways. Okay. Okay, next, suppose here the total number of favorable cases is ACX into BCX. Okay. Next concept. N balls can be drawn from A plus B balls, which is the in A plus B Cn base, which is the total number of possible outcomes, possible cases is which is the possible number of cases is A plus B Cn. Okay. Next, the probability of getting X white ball, the probability of getting X white ball out of n is ACX BCn minus x divided by A plus B Cn. ACX BCn minus x divided by A plus Cn. It is an example. Once again, consider an urn contains A white balls and B red balls. Here A is a white ball and B is a red balls. Suppose we draw a sample of n balls at random from an urn. Suppose we draw n balls random from an urn. Then X white balls can be drawn from A white balls. Then see, X white balls can be drawn from A white balls in ACX ways. And n minus x red balls can be drawn from B red balls. N minus x red balls can be drawn from B red balls in BC n minus x ways. Okay. Here the total number of favorable cases is ACX into BC n minus x. That's what it. Okay. Next is n balls can be drawn from A plus B balls. N balls can be drawn from A plus B balls in A plus B Cn, which is the total number of possible cases, that is A plus B Cn. Okay. Here the probability of getting X white balls, out of n is, ACX into BCn minus x divided by A plus B Cn. It is the main concept of hypergeometric distribution. Okay. Next, let us discuss the definition of hypergeometric distribution. hypergeometric distribution. Here definition. Let x be a discrete random variable, same as it is. Let if x be a discrete random variable, with the probability mass function, is P of x equal to ACX into BCN minus x divided by A plus B CN. With the probability mass function is P of x equal to ACX into BCN minus x divided by A plus CN. Where x takes the values 0, 1, 2 up to so on minimum of A comma n. Your range is x takes the values 0, 1, 2 up to so on minimum of A comma n. Then the distribution of x is called as hypergeometric distribution. Then the distribution of x is called as hypergeometric distribution. Let's write it once again. If x be a discrete random variable with the probability mass function is P of x equal to ACX into BCN minus x divided by A plus BCN, and then x takes the values 0, 1, 2 up to so on minimum of A comma n. Then the distribution of x is called as a hypergeometric distribution or hypergeometric variant. Okay, here A, B and n are the three parameters of hypergeometric distribution. Here A, B and n are the parameters are the positive integers and n is less than or equal to A plus B and n is less than or equal to A plus B. Here A, B and n are the positive integers and n is less than or equal to A plus B. Okay, here the hypergeometric distribution with the parameters A, B and n is denoted by H of A, B, n. Here the hypergeometric distribution with the parameters A, B and n is denoted by H of A, B, n. Okay, the hypergeometric distribution with the hypergeometric distribution with A equal to 3, B equal to 4, A equal to 3, B equal to 4 and n equal to 5 is written as follows. Okay, here range minimum of A comma n, it is equal to minimum of A comma n. Here A value is 3 and n value is 5. Minimum value is 3. Okay, A comma 3. Therefore x equal to 0, 1, 2, 3. X equal to 0, 1, 2 and 3. Range is 0 to 3. Minimum value is 3, therefore range is up to 3. Okay, here you have to write the hypergeometric distribution. Here x takes the values 0, 1, 2, 3. X takes the values 0, 1, 2 and 3. Okay, with respect to p of x, substitute x is 0 and okay, substitute the values a is 3, b is 4 and n is 5 and substitute x equal to 0, that is acx. Okay, acx is the okay, a value is 3, 3c 0, x value is 0 into b value is 4, 4c n minus x, n value is 5, 5 minus 0 is 5 divided by a plus b, 3 plus 4 7. Okay, a plus b cn, okay, 7c 5. Okay, the next put x equal to 1, 3c1 4c, 5 minus 1 is 4 divided by 7c5. The next 3c2, put x equal to 3c2 into 4c, okay, 5 minus 2 is 3, 4c3 divided by 7c5. Put x equal to 3, 3c3 into 4c, okay, 4c, 5 minus 3 is 2 divided by 7c5. Here total is 1. The sum of the probabilities is always equal to 1. The sum of the p of x here, therefore sum of p of x is exactly 1. Sum of p of x is exactly 1. Sum of p of x is exactly 1. Sum of the probabilities is exactly 1. Okay. Next concept is the properties of hypergeometric distribution. The next properties of hypergeometric distribution. Properties of hypergeometric distribution. Here the first property is A, B and N are the parameters of hypergeometric distributions. A, B and N are the parameters of hypergeometric distribution, HGD. N, A, B and N are the parameters of hypergeometric distribution. Second property, for a hypergeometric distribution, for a HGD hypergeometric distribution, the PMF is P of x equal to ACX BCN minus x divided by A plus B Cn, where x takes the values 0, 1, 2 up to so on, minimum of A comma n. X takes the values 0 to minimum of A comma n. That is the second property. Third property, x equal to 0, 1, 2 up to so on, minimum of A comma n is the range of HGD, is the range of hypergeometric distribution. Okay. Next, fourth property, for a hypergeometric distribution, mean is NA by A plus B, mean is NA by A plus B, variance is NAB into A plus B minus N divided by A plus B whole square into A plus B minus 1, and standard deviation is under root of NAB into a plus b minus m divided by a plus b whole square into a plus b minus 1. Okay, this is fourth property here. For a hypergeometric distribution, mean is na by a plus b, variance is nab into a plus b minus n divided by a plus b whole square into a plus b minus 1, and standard deviation is under root of nab into a plus b minus n divided by a plus b whole square into a plus b minus 1. Okay, next fourth property. The hypergeometric distribution tends to binomial distribution. The hypergeometric distribution tends to the hypergeometric distribution tends to binomial distribution. Binomial distribution. When a plus b tends to infinity, a plus b tends to infinity, and a by a plus b equal to b, and a by a plus b equal to b. Here under the what conditions hypergeometric distribution tends to binomial distribution? It is a 2 marks question. Here the first condition is a plus b tends to infinity. Suppose if a plus b values are large, then hypergeometric distribution tends to binomial distribution. Second condition is we want p value. What is the p? P is a parameter value for a binomial distribution. P equal to what? A divided by a plus b. Then we get the p value. Okay, these are the properties of hypergeometric distribution. Once again, the first property is a, b, and n are the parameters of hypergeometric distribution. Second one is for a hypergeometric distribution, the PMF is P of x equal to ACX BCN minus x divided by a plus BCN, where x takes the values 0 to the minimum of a comma n. Okay, third property, x equal to 0, 1 to up to so on, minimum of a comma n is the range of hypergeometric distribution. Fourth one is for hypergeometric distribution, mean is na by a plus b, variance is nab into a plus b minus n divided by a plus b whole square into a plus b minus 1, and standard deviation is under root of nab into a plus b minus n divided by a plus b whole square into a plus b minus 1. And last property is the hypergeometric distribution tends to binomial distribution under the following conditions. The first condition is a plus b tends to infinity, and second condition is a by a plus b equal to p. Okay, these are the properties of hypergeometric distribution. Properties are the features of hypergeometric distribution. Okay. Next, let us discuss the examples for hypergeometric distribution. Examples for hypergeometric distribution. Examples for, okay, write any two examples for hypergeometric distribution. It is a 2 marks question. The first example is the number of white balls in a selection of white balls in a selection of three balls. Number of white balls in a selection of 3 balls in which there are 4 white balls and 5 black balls in a box. Here, first example is what? The number of white balls in a selection of 3 balls in which there are 4 white balls and 5 black balls in a box. Okay, here the totally a box contains there totally how many balls are there? 4 plus 5 is 9. 9 balls. Okay, out of 9 balls, 3 balls are randomly drawn. Out of 9 balls, 3 balls are randomly drawn. Then what is the probability of getting white balls? Then what is the probability of getting white ball? That is the probability of x equal to white. Here x indicates a white ball. Here the number of white balls, a selection of 3 balls in which there are 4 white and 5 black balls in a box. Here 4 is a that is white ball and B is a black ball and N. Okay, out of these 3 balls are randomly drawn. Here N equal to 3. Okay, N equal to 3. We have to find probability of white balls. Probability of white balls. That is, you have to apply the formula that is PMF, that is ACX into BCL minus X divided by A plus B CL. Okay, this is the first example. Second one, the number of boys in a committee the number of boys in a committee of selection of 4 students in which there are 10 boys and 8 girls. In which there are 10 boys and 8 girls. Okay, listen once again. Here in a class there are totally 18 students are there. Out of 18, 10 boys and remaining are girls. Okay, 10 boys and 8 are girls. Here A is a 10 and B is 8. Okay, A plus B is what? 18. Out of these 4 students are randomly drawn. Out of 18 students, 4 are randomly drawn. Then what is the probability of getting boys? That is the number of boys in a committee of selection of 4 students in which there are 10 boys and 8 are girls. Okay. The next one more example. The number of vegetarians in a selection of 5 students from hostel in which there are 20 vegetarians and 25 non-vegetarians. Here once again, the number of vegetarians is a selection of 5 students from hostel in which there are 20 vegetarians and 25 non-vegetarians. Here A is 20 and B is 25. There are totally 45 students are there. Out of 45, 5 students are randomly selected. Then what is the probability of getting vegetarians? Okay, these are the examples for hypergeometric distribution. Okay. In the next class, we shall discuss the problems based on hypergeometric distribution. Thank you.